Okay, welcome to our next session. So we are going to continue on our Truss analysis. So last time we had solved a single problem on trusses using the method of joints. So let us have another example. So we have here a truss loaded as shown. Of course, the very first step is to determine the corresponding support reactions, particularly on point A and at point E. So working with the reactions, let us label all the support reactions. Of course, at point A, we have here a horizontal and vertical, but obviously horizontal has no value since there is cannot find any horizontal force there. And let us assume that we have here an upward RE and an upward RE on this side. So again, we solve for the reaction by summation moments and then check it by summation forces vertical. So by summation moments at A, we have clockwise 2000 times moment arm of 5 plus 4000 times 10 plus 3000 times 15, okay, minus RE times 20 is equal 0. So we get RE is equal to 4,750 pounds. So for the other reaction, we take moments at B and equate it to 0. So we have a counterclockwise 3,000 times 5 minus 4,000 times 10 plus a clockwise RE times 10 less counterclockwise 2000 times 15 is equal to 0. So I think we should have a distance for RE equivalent to 20 so that RE would be equal to 4,250 pounds. So with this, we are going to check our reaction before proceeding to the analysis proper. So we can do that by summing up forces vertical. We have downwards negative 2000 less 3000, another downwards negative 4000, then the upwards reaction 4750 and 4250, that shall be equal to 0. So if we're going to compute that, it is really equal to 0. Okay, so now that we are assured of our reaction, we can now proceed to our analysis. So this is done by joint method for the meantime. So of course, we have introduced how to do that. We go joint per joint, but we do not have to illustrate an x and y axis for each of the joints. So we'll just utilize horizontal forces, that horizontal, vertical, and a diagonal. So remember that the diagonal forces should have their components. Okay, so the basic first step is to choose the joint where there are only two force members. So in this case, obviously, we have the edges as the simplest joint to work with. We have A and E. So starting at A, we have 4,250. So 4,250 is an upward force. So let us choose between AC and AB, where it will resist RA is equal to 4,250. So obviously AC will have no uh, vertical first force, so it has nothing to do with 4,250. So therefore, RA should be countered by AB alone. So particularly its vertical component. Therefore, AB should be going towards the joint, or it is in compression. Why? Because again, RA should be countered by the vertical component of AB. So by the force triangle, we have a vertical 4,250 and the horizontal component for AB, that is ABX. So we have the force triangle to work with. We can obtain ABX by tangent function. Tangent 60 degrees is equal to opposite for 250 all over ABX. Therefore, ABX is for 250 all over tangent 60. We have 2,453.74 pounds. So we already obtained the components of AB along X and along Y. So we will just use them in order to solve the mother force or the diagonal force AB. So we can simply do that by the Pythagorean theorem, that AB is equal to the sum of the squares of its component and then get the square root. So we have 4,907.48. We're gonna place it here. So AB now here is a 4,907.48 compression. And remember, at point A, we have just balanced the vertical axis, creating an imbalance to the horizontal axis at A. So we also need to balance the horizontal axis at A. So for this time, as we can see in the diagonal force AB, looking at point A, AB is towards left, okay? So there will be no other force to counter this horizontal force ABX, equivalent to 2,453.74, that is leftward. So therefore, it will be countered by no other force than AC. So here it is. This should be 2,453.74, or the value of ABX being countered now by AC. So that balances our joint A. First, we have balanced the vertical and then followed by the horizontal. So moving on, we proceed to joint B. And as we can see, there are two diagonals and a horizontal member here. So basically, we wanted to ask ourselves what axis is most convenient if we're going to work with B. So in this case, there are two force members along the Y axis. As of the moment, we have a downwards 2,000 here and an upwards 4,250. So again, there is no other force to make a balanced force under the vertical rather than BC, because BD has nothing to do with the vertical, because BD is a horizontal force or a purely horizontal force. So therefore, only the vertical component of BC shall balance our vertical for B. So by that, again, we draw the force triangle. Here it is. So rationally thinking, there will be an upward 4,250 and a downward 2,000 at joint B. And as a result, a vertical 2,250 upwards shall prevail. So if that prevails between 4,250 and 2,000 here, therefore, it will be needing a supplemental force downwards equivalent to 2,250. So here it is, the component of BC. So we indicate the direction at joint B. So it is going that direction, or actually that is tension, in order to adhere with a downward force 2,250. So if we are going to review this, an upward 4,250, downward 2,000, downward 2,250, that will yield us to zero force under vertical loading. So our next concern now is the horizontal. First, we need to obtain BCX by function of, again, we are going to use tangent. Tangent 60 degrees is equal to 2,250 all over the known BCX. So therefore, BCX is 2,250 all over tangent of 60. And that is equivalent to 1,299.04. Now that we have obtained that, let us note here that there are rightward forces caused by these two diagonal forces, AB and BC. That is a rightwards BCX and ABX and BCX. So by a rational assessment, therefore BD is just the sum of ABX and BCX against a rightward direction. So it should be a leftward direction for BD, summing up ABX and BCX. We have BD is equal to ABX plus BCX. So let us check the value of ABX. So we can see that ABX is this one. We have 2,453.74. We're gonna place it here. And then for BCX, we have here the value. We're gonna place it there. And that sums to 3,752.78 for BD. And that is leftwards along B to counter our rightward force ABX and BCX. So if it is leftwards at B, of course, it is towards B. Therefore, if it is towards B, it is compression. And as an effect, this is also towards D, or consistently BD is in compression. Here it is. We have 3,752.78. We proceed further. So I think the best way that, or the best joint we're going to consider right now is at joint E. Similarly, we're going to have the procedure that was done in joint A. We place here 4,750 and that is countered by 4,750 here, the DE, and that balances our vertical. So proceed to the horizontal at point E. Of course, we need to find DEX, and that could be found by tangent function. Tangent 60 degrees is equal to 4,750 all over DEX. That is 4,750 all over tangent 60. We have 2,742.41 pounds for DEX. And that will be also the value for CE. That is compression. So actually it's against the direction of DEX. That should be leftwards. So we will change that and place the value. Then we have now a balanced force on the x and y axis along joint E. So by this, we can now solve for value of DE by Pythagorean theorem. We just have to square the y component and square the x component and then get the square root. So we have 5,484.83 as a force for member DE. So there is one more left, that is member CD. Similarly, we're going to place the force triangle. This time you can choose either the vertical or horizontal, since CD is the force on the left force only. So looking at the vertical forces, we have here an upward 2,250, a downward 4,000 pounds. Therefore, we should require an upward 1,750. So it follows that this force is in tension. Then we should obtain the horizontal component CDX by tangent function again. So we have 1010.36. So we are now complete on the forces. And then we should realize that we have a complete sets along y and along x here. So what we do is to investigate whether our forces along x and y will yield to a balanced force, or simply it will yield to a sum of equal to 0. So of course we are done with the vertical. So on C we are going to have an investigation on horizontal force. So you can actually direct it in your calculator. So if we have a leftward that is negative, and if we have a rightward force that is negative. So we go directly in our calculation. First, we have here negative 2453.74 because that is leftwards. And another leftwards BCX, which is 1299.04, plus CDX, which is 1010.36, plus another rightward force that is CE, equivalent to 2742.71. Summing all of those, we have equal to 0. So in short, there is a balance now between vertical and horizontal along joint C. So remember that joint C is the last joint that we have worked on, and CD yielded to certain CDX here, and then upon checking it yielded to 0 along X and along the Y direction. So therefore our analysis is correct in a way that we have balanced all of the joints. So of course we wanted to compute for the force member of CD upon these components CDX and CDY. That is 2020.72 for CD, and then for BC we have to obtain this value by its component 2250 and BCX, and that is equivalent to 2598.06. So that is about our analysis for today. So please stand by for the next problem on Truss analysis.